Hi there, so today we are looking at the group 1 metals and we're going to find out what their properties are and yet answer why are they so reactive, look at their reactions, predict properties, and then we're going to be doing some exam style questions at the end. So first of all, the properties of the group 1 metals. So with the groups that we're going to be looking at, we're always going to be looking at how the property changes going down the group. So here we go, we've got the group here. So we're going to look at how it changes going down the group. So first of all, we're going to be looking at melting point. So melting point is increasing as we go down the group. And the reason for this is because we have weaker metallic bonding. So the weaker metallic bonding is coming from the fact that the atoms are just getting quite big. So if we do a quick little sketch of metallic bonding, so if you want a full lecture on what is going on with this, you can look at a previous video. So we have our regular arrangement of positive metal ions, and then we have our sea of delocalized electrons. So when we're going down the group, the metallic bond is getting weaker, and that's just because the interaction between the positive metal ions and the negative electrons, that gap is kind of getting bigger. So with our bigger metal ions, the metallic bond is getting weaker. So if I keep this the same, and then if I change this part of the diagram over here, so with our bigger atoms, we have a bigger gap between the electrons and the positive metal ions. So this is why the metallic bonding is getting weaker as we go down the group. They also become softer. So I don't know if you've done this demonstration in school, but the so lithium's like the hardest to cut, and then potassium is the last one you're allowed in school, and potassium is really easy to cut, and that's because you have the weaker metallic bonding. Okay, so let's clear some space so we can talk about our next point. So density is increasing. So the density is increasing because we have basically a bigger mass number. So if I just draw very roughly, so if we have, so lithium can kind of look a little bit like this. If we compare this to, say, rubidium, so rubidium is much bigger, but it also has a much heavier nucleus. There's so many more nucleons in the nucleus of rubidium. So if we just have a little look here and compare this, so rubidium basically has 85 nucleons and lithium has 7. So even though yes, rubidium is a bigger atom, it has so many more nucleons in the nucleus, so that's why the density is increasing by so much. And our last thing is reactivity. So reactivity is increasing as you go down the group, and this is because it's easier for the bigger atoms to lose their outer shell electrons. So if we can remember, all of the elements want to have a full outer shell. They can either do this by gaining electrons or losing electrons. With the metals, in group 1 especially, they want to be losing electrons, and it's very easy for them to lose 1 electron because they've got 1 electron in the outer shell, that's why they're group 1, compared to gaining 7 electrons. So we've got our 2 atoms drawn here, and we can imagine what I've drawn is the outer shell. So we've got an electron in the outer shell. So the distance, let's make this diagram a bit better. So the distance from the positive nucleus, and so the distance between the negative electron and the positive nucleus is just getting larger. So that means it's harder for the positive nucleus to hold onto that electron, which makes it, it makes it easier to lose. So because it's easier to lose, it can undergo reactions quicker, and that's why reactivity is increasing. So this is why reactivity is increasing going down the group. So these 3 metals, hopefully you've seen their reaction in school. So lithium does react pretty vigorously with water. So not many things just react with cold water. So lithium reacts with cold water, but the reaction with potassium is noticeably more. And that's because it's losing its electron quicker and easier than the lithium. All right, so let's have a look at the reactions that the group 1 metals undergo. So with the metals that I've put here, you could change these for any metal, and yeah, the equations would be the same. So what's the first thing that they do? So like we've already been speaking about, they react with water. They react with water very quickly and easily. So in this case, we've got potassium reacting with water, and it forms potassium hydroxide and hydrogen. So yeah, so this reaction happens very quickly, very easily. The potassium is the most reactive. You'll see it fizzing and bubbling, fizzing on the surface, creating hydrogen gas. It floats, which is pretty interesting, it's pretty cool. And it also melts and it turns into a ball. Oh yeah, because it has melted, because the temperature of the reaction is hot enough to melt it. So this ball is fizzing, whizzing around the surface of the water, and it has a lovely lilac coloured flame, and it keeps going until the end, and then it does like a little pop. And yeah, that's the end of that reaction. So yeah, so sodium does the same. So sodium again fizzes, giving off hydrogen, and then if the hydrogen does catch fire, then that burns with more of an orange flame. And then the lithium is the least reactive, again reacting with water, giving you a hydroxide solution. But this one does not catch fire. So other reactions that they do, so they react with oxygen. So it's not a very vigorous reaction, but it does happen at room temperature. So if you leave the metal out, it will react with oxygen. So yeah, if you have seen these metals in real life, they are stored in oil, and this is to prevent the reaction with oxygen, but it does still happen. So they're kind of covered with an oxide layer, so in this case lithium oxide, and it's quite dull compared to the shiny metal. When you cut it, you open it up, you can see that it's a nice shiny metal on the inside. And of course they react with the non-metals. So metals react with non-metal, so group 1 likes to react with group 7, as we've seen from the ionic bonding video, and you end up with an ionic compound. And this is a really good reaction just to show you how elements are different to a compound. So we've got two elements reacting together, and then the compound that is formed is very different. So a very soft reactive metal, a very reactive gas, and then what you have is a very unreactive white solid with a high melting and boiling point. So with all of these, like I've already said, you can be changing this metal for any of the other group 1 metals, and the layout of the equations is going to be exactly the same. Okay, so now on to predicting the properties. So this is with a focus of group 1, but this is true for all of the periodic table, because everything in a group kind of has similar properties, and the property changes as you go down the group. So if you kind of you study these elements quite a lot, and if you understand these properties and how they change, then you can kind of figure out what's going on lower down the group. So this is probably best illustrated with a question. So we've got a cheeky question, sneaky, and before we get onto our questions in a minute. So here we have a table. The table is showing us the melting points of the first 3 alkali metals, the group 1 metals. And our first question here, describe the trend in melting point as you move down the group. So so we're describing, so we're just basically saying what we see. And as we're going down, we can see that there is an increase in melting point. Nice and easy. Now on to an explain question. So explain in terms of atomic structure and bonding why this trend occurs. So this is what we've already been talking about. So it's to do with metallic bonding. So as you're going down the group, the metallic bonding is getting weaker, and therefore because it's getting weaker, it is easier, or you need less energy to convert it from a solid into a liquid, which is what a melting point is a measure of. And then this is a very common question, so predicting the melting point for rubidium, or we could even for any of the metals that we don't have data for. So you just need to make an educated guess. So when it comes to the mark scheme, it won't just be one answer, it'll be a range. So we kind of need to be looking at what is the gap between the first one and the second one. So we've got a very big gap here, and then a smaller gap here. So I'll probably go for something that's similar with this gap. So this is a gap of about 30. This is a gap of around about 80. So we can see the gaps are getting less. So we want to be going for something less than 30. 30 degrees less, so let's say around 20 degrees less. So if we went for an answer of, let's say, 45 degrees Celsius. That is probably going to be in our range. Okay, so there we go. Now on to our final thing, some exam style questions. So because you are very, very lucky people, I have given you 6 exam questions, all for free. Happy days. I'm not going to go through all of them, so you can go through these at your leisure. I'll just go through question 1 and question 2. You can do the other 4 on your own. But yeah, if you need some extra help with them, then you can ask for help in the comments and I can check your answers there. Or if you want even more help, then this is a perfect opportunity to check out my website where you can get some chemistry tutoring from me. So yeah, the link for my website is in the description. So what do we have here? We've got our first question. So question 1. So we've got 3 metals. In group 1 of the periodic table, state the general trend in reactivity as you move down the group. Okay, we've been doing this. So the general trend is that there is an increase in reactivity as you go down the group. Nice and easy. And now, yeah, explain in terms of electronic configuration why this trend occurs. So again, we've got an explain question. So what is going on as you're going down the group? The outer shell electron is further away from the positive nucleus. So therefore it's easier for the elements that are lower down the group to lose their outer shell electron. And they're losing the electrons here, so we're explaining why do they want to lose the electron. They're losing the electron because they want to have a full outer shell, which is the electronic configuration that all the elements are after. Okay, on to question 2. So yeah, a small piece of sodium is added to a trough of cold water. List 3 observations that can be made during this reaction. So observation number 1 is that the sodium will melt and form a ball. Observation number 2 is that it floats on the surface. Observation number 3 is that it fizzes as a gas is given off. We can even have observation number 4 is that if the flame or if the gas does ignite, then it would burn with an orange color. So there we go, lots of observations. Write a balanced chemical equation, including state symbols, for this reaction. So I will write this one down. So with balanced equations, I always write out the symbols first and then go back and balance it. It's always a good habit to kind of get into. So what do we have? We have sodium. So sodium is a solid and it is reacting with water, which is a liquid. And we are getting sodium hydroxide, which is aqueous. And this is the correct formula for sodium hydroxide, because yeah, sodium's in group 1. It has a plus charge. We need to start remembering the charges of the compound ion. So hydroxide is -1. So we can do the crossing over valency method to figure out that this is, yeah, the correct formula. But yeah, the plus and the minus cancel each other out. So there we go. And we have hydrogen, which is a gas. Okay, and yeah, and hydrogen is always H2. Now we need to balance the equation, so we need to see what have we got. So we can see, yeah, the hydrogen is the thing that isn't balancing. So we've got an odd number of hydrogens over here and even over here. So we want to get them both to be even. So we can start off by putting a 2 over here. So now the hydrogens are not balanced, but they are both an even number. So this makes things a bit easier. But yeah, now we can balance the sodium. So we've got a 2 here, and we need a 2 here to then, yeah, balance the hydrogen and oxygen. Okay, happy days. Now onto our final question. Explain why the resulting solution has a pH greater than 7. And it has a pH greater than 7 because you have made something that is alkali. So if you have more OH than H in your solution, so more hydroxide ions than the hydrogen ion in your solution, then your pH is going to be greater than 7. And that's exactly what's happening when you form sodium hydroxide. So the hydrogen is leaving, so we're getting some hydrogen is leaving in the form of, yeah, hydrogen gas. But that's more for a future topic, but anyway, there we go. So there we are. So yeah, like I've said before, have a go with those other 4 questions. Leave your answers or any problems you might have in the comments and I can get back to you then. Or if you need even more help, then yeah, check out my website for links. Check out my website, which tells you how you can get in contact and you can have some one-on-one chemistry tutoring. Okay, so that is everything from me. Thank you as always for watching, and yeah, it would mean a huge deal if you could tell everyone who is in need of some extra chemistry help about this channel. And yeah, the more people who subscribe, the more likes we get, then the more videos that get made. All right, thank you again, and yeah, I will catch you in the next one. Ciao.